Let's solve for sine of inverse secant of u, or sin sec minus 1. U. This is a complex expression that we can break down step by step using trigonometric identities. Let's start by drawing a right triangle to help us visualize this. First, let's understand what sec minus 1 u means. If we call this angle theta, then secant of theta equals u. Remember that secant is the ratio of the hypotenuse to the adjacent side. Let's label our triangle sides. The hypotenuse is r, the adjacent side is x, and the opposite side is y. Since secant theta equals u, we can write that our over x equals u. This means that r equals u times x. Now we can use the Pythagorean theorem. X squared plus y squared equals r squared. Substituting r equals u times x into the Pythagorean theorem, we get x squared plus y squared equals u squared x squared. Rearranging terms, y squared equals u squared x squared minus x squared, which simplifies to x squared times quantity u squared minus 1. Now, remember that sine of theta equals opposite over hypotenuse, which is y over r, and we know that r equals u times x. Substituting our expression for y squared, we get that sine of inverse secant of u equals the square root of u squared minus 1 all over u, and that's our final answer. We've successfully found the expression for sine of inverse secant of u using trigonometric identities and right triangle geometry.